Welcome to section 6.2. In this section, we're going to be looking at some further application of integration and finding area under a curve and area between curves in the form of consumers and producers surplus. So we're in the realm of economics a little bit here. So we're going to talk a little bit about supply and demand and talk about how we can determine surplus. So, in general, the market tends toward what we call equilibrium. So we have equilibrium price and equilibrium quantity. Equilibrium price is abbreviated P sub E, and quantity is abbreviated X sub E. So if we look at our graph over here, we have the supply curve and the demand curve. The equilibrium point is going to be this point right here. Okay, so this is equilibrium. This is where supply and demand are equal. So this is what we're aiming for as like an economy. So as producers and consumers. So we have the equilibrium price, so P sub E, and equilibrium quantity demanded, X sub E. So the quantity demanded is right here. The price that is being charged is right here. Now, an important thing to take note of with equilibrium, equilibrium is kind of like a compromise. It's kind of a win-win situation for everybody. The producers don't get to charge maybe as much as they want, but they are charging a satisfactory amount. And consumers, maybe they don't get as low of a price as they want, but they're not getting charged too high of a price. So the idea of surplus comes in here. So many consumers are willing to pay more than this amount, and many producers are willing to charge less than this amount. So if I'm a consumer and I'm purchasing a product, I may be willing to spend up to, $10, $20 for this item. The company is only charging $5 for the item. So all I have to pay is $5. I would have been willing to pay up to, $10 or whatever it may be. If you compile this for all consumers, there are many, many people who would have paid these higher prices up here. They have now saved money. We could say gained money by not spending it. They have created a surplus for themselves. So all of this extra money is being saved by the consumer. That is what we call consumer surplus. So the consumer's surplus, often abbreviated CS, measures the consumer's gain. It is the total amount gained by consumers by buying the item at the current price rather than the price they would have been willing to accept. Okay, so again, many consumers are willing to pay more money. Okay, not everyone, but enough are willing to pay more money than the current equilibrium price. And so that extra money that they have saved or gained by not spending it is the consumer's surplus. Now, producers, so these are the ones making the products, they are also willing to charge less for a product if they have to. Okay, so they could still charge these lower price amounts and still potentially make revenue, make profit, all of that good stuff. But they don't have to charge these really low prices because the consumers are buying it at equilibrium. So this amount of money that they're gaining extra is the producer's surplus. So the producer's surplus, which is abbreviated PS, measures the supplier's gain. It is the total amount gained by producers by selling at the current price rather than the price they would have been willing to accept. So again, for the same product, the producer is currently charging $5 for the product. They would have been willing to charge as little as $3 for the product. But they get to charge $5 because that's where equilibrium is. That's where the balance is. That extra money they gain on top of what they would have been willing to charge, that is their surplus. So like I said, equilibrium is kind of that win-win situation. Consumers get to spend a little bit less than they would have, and producers get to charge a little bit more than they would have, and it kind of balances there. Now, how do we calculate these? Well, if all consumers who were willing to pay more than, I need to fix this. This is P star. If you look in other texts, they'll sometimes use the star notation instead of the E notation. So if you see that anywhere, it's the same thing, but this is PE. If all consumers who were willing to pay more than equilibrium price paid as much as they were willing, then that would give us what we call total consumer expenditure. Total consumer expenditure. So this would be, so if we have, this is the demand curve, this is the supply curve, here's equilibrium price and equilibrium quantity. Total consumer expenditure is going to be the integral from 0 up to x sub e of f of x dx, where f of x is going to represent the demand formula. So this is the area under demand from 0 to x sub e. So here's our demand curve going down to here. So everything in here would be the total consumer expenditure. This is all the money that people are spending up to equilibrium and what they would be willing to spend beyond equilibrium. That's everything. So that would be the total consumer expenditure. Their actual expenditure at equilibrium is the area of the rectangle PEXE. So it's the area of this rectangle. So when the price being charged is the equilibrium price, they are actually spending this much money. Okay? They would be willing to spend this much more. So the total consumer expenditure is just the sum of those two. So how do we get consumer surplus and producer surplus at equilibrium? Well, the consumer surplus, let me try to color code here. the consumer surplus at equilibrium is going to be the area between the demand curve and the horizontal line at PE. So again, this is what they're actually spending down here. What they would be willing to spend is up here. And again, this is considered consumer surplus because they don't have to spend this. Because they're being charged the equilibrium price, they are saving all this money collectively that they now don't have to spend. So that's our consumer surplus, is that area right there. For producer surplus, this is the amount of money the producers are making by charging a slightly higher price at equilibrium. That's going to be the area between the supply curve and the horizontal line at PE. So that's going to be this area right here. So that's producer surplus right there. So let's take a look at an example with some actual numbers in it. So given the supply and demand curves below, at the equilibrium price, calculate and interpret the consumer and producer surplus. So for this one, these are straight lines. So we don't even really need to get into the integration just yet, because when we're dealing with straight lines, all of these areas are geometric. So we know that this area up here between equilibrium price and the demand function, that's going to be our consumer surplus. And then this area down here between equilibrium price and the supply curve is the producer surplus. All right, so we can go ahead and calculate these geometrically, right? Because these are both right triangles. So our consumer surplus is 1/2 base times height. The base here is 80,000. So there are 80,000 being sold right now, or being demanded right now, times the height. The height is not 240. It is only that portion of the height, which is 240 minus 80, which is going to be 160. So if we run those big numbers, we end up with 6,400,000. So 6.4 million. And then our producer surplus, we can do the same kind of thing. 1/2 base times height. So the base is again 80,000. And the height is 80. So really, it's the same thing, just cut in half, because we went from 160 to 80. So that's 3.2 million. So now let's take these numerical values we got and interpret them. So I've got a couple statements down here already ready for us. So the consumers are currently gaining That's the 6.4 million. So $6,400,000 by purchasing at equilibrium instead of the price they would have been willing to pay. And again, this is speaking collectively. This is for all consumers, not just one person saving $6.4 million. So the consumers have a surplus of over $6 million. Producers gain $3,200,000 by supplying at equilibrium instead of the price they would have been willing to charge. So getting to charge at equilibrium price gained them some extra money. Collectively, they gained $3.2 million. Now, like I mentioned, this problem is nice because it deals in straight lines. A lot of times we're not going to be working with straight lines, so we need to take that into account. So you can see right here in our next example, the demand for a particular item is given by the function d of x equals 1450 minus 3x squared. Find the consumer surplus if the equilibrium price of a unit is $250. Okay, so a couple things that we know about this, the values on this function. This is a downward opening parabola. Obviously, I've already sketched the piece of it in the positive direction here. We know that its height would be 1450. So that's going to be right there. And we know that the equilibrium price is at 250. So that's going to be somewhere down here. Okay, not drawn to scale necessarily. So the consumer surplus is going to be this area up here. So this is our consumer surplus. So in order to find the area here, we need to set up an integral. And this is not just an integral under the curve, it's an integral between this curve and this line. So we need to set this up. So we're going to have 1450 minus 3x squared minus 250 for the line. Now for the bounds, of course, it's going to start at 0 on the left-hand side. But the issue is it's not going to go all the way to where this function hits the x-axis. It's actually going to stop here at the equilibrium quantity, that quantity demanded. So we're looking for x sub e. And we can find that by using this formula, because we want this point right here where our function equals 250. So we'll go ahead and take our function. So d of x equals 1450 minus 3xe squared. And then we'll set this equal to 250. So if I add this over, subtract that over, we get 3xe squared equals 1200. So xe squared is 400. So xe must be 20. Okay, and technically, like mathematically, there would be a plus or minus on there. But because we're dealing in the context of like physical items and physical dollar amounts, having a negative number of items demanded wouldn't make any sense. So we just keep the positive 20. So this value is 20. So we're going to go from 0 to 20. So we have integral 0 to 20 of 1250 minus 3x squared dx. So combine those two. So we have that's 1250x minus x cubed, evaluated from 0 to 20. So we get 1250 times 20 minus 20 cubed minus the 0 case, just turns everything into 0. This ends up working out to 16,000, which then in context would be $16,000 in consumer surplus. So the consumers have gained $16,000 by not spending higher prices and rather just paying the $250 at equilibrium. Right. So let's take a look at another example. Find both the consumer's and producer's surplus for a product with the given demand and supply equations. All right, so our equilibrium point is right here. So that's where these meet. All right, so everything up here is going to be consumer surplus, and everything down here is producer surplus. Now in this case, we are not given the price at equilibrium. That's something we're going to have to figure out for ourselves. So we can do that by finding the intersection point. So we're just going to set these two equations equal to each other. So 25 minus 0.005x squared. And we set that equal to 0.004 x squared. And it doesn't take too much to solve for x here, but it does, it is one of those that kind of lends itself to calculator work. So if I move this decimal over 3, so that's 9x squared equals 25,000. So x squared is 25,000 over 9. That's going to give us that our equilibrium quantity is the square root of this number, which the furthest you can simplify that down to is 50 root 10 over 3. And that would be the exact value, but just so that we can get a feel of where this number is, that's approximately 52.7. So this number down here is about 52.7. To get the corresponding price, you can substitute this back into either of these equations to get equilibrium price. So that's going to be approximately 11.11 dollars. So we've got 11.11. Now we have the tools that we need to solve for both of these. So let's do consumer surplus first. So consumer surplus, that's the integral from 0 to 52.7. Area under the demand curve minus the area under that line. So let's see here. Integral 0 to 52.7. 25 minus 1111 is 13.89 minus 0.005x squared dx. So we take the antiderivative. That's 13.89x minus 0.005 over 3 x cubed from 0 to 52.7. If we run that through a calculator and round to the nearest cent, we get $488.06. So that would be our consumer surplus. And then the producer surplus, it's also being evaluated from 0 to 52.7, but now we're under the line. So 1111 comes first, minus the supply equation, so 0.004x squared dx. So we can go ahead and take the antiderivative. So that's 11.11x minus 0.004 over 3x cubed from 0 to 52.7. Do the evaluation and round to the nearest cent. We're going to get approximately $390.35. So that means that by charging $11.11 for this product, the producers are gaining an extra $390 over what they would have been willing to make. And by paying $11.11, the consumers are saving $488 that they would have spent otherwise. And if you're looking any further past this, the numbers that we come up with here, so just as a separate kind of a side note, if we were looking for the idea of like total surplus, this is the amount gained by both the consumers and the producers. You would just take consumer surplus plus producer surplus. That gives an idea of how much has been gained collectively among all sides of this. The question didn't ask for that though, but just so you know, that there are cases where we would take these numbers and add them together. All right, let's take a look at another example. So we have a similar case here. So the demand and supply for a particular type of chemical glassware is modeled by these two functions for demand and supply, respectively, where X is the number of glassware units in thousands demanded and supplied, and both these formulas are the glassware unit prices in dollars. Okay, so we've got glassware units in thousands, and we've got prices in dollars. Find the consumer surplus and the producer surplus. So it's basically the same as the previous problem. We just have different formulas, right? Different functions. Okay, so we're going to tackle this the same way that we tackled the last one. So we would go ahead and equate these. And if we go through this process, so that's going to be 0.0012 x squared plus 0.03x minus 54 equals 0. We end up getting an equilibrium quantity of 200. Equilibrium quantity of 200, and we plug that back into either of them to get the equilibrium price, which is going to be 114. And if you want to check my algebra on that, by all means, go ahead. So we're going to have this area up here will be our consumer surplus. There's our 114. There's our 200. And then we have the area down here. That is our producer surplus. All right, so let's get consumer surplus first. That's going to be the integral from 0 to 200 under the demand curve above the line, like that. So we have integral 0 to 200 negative 0.001 x squared plus 40 dx. So that gives us, let's see, divide by 3, x cubed, and then 40x, evaluated from 0 to 200. Evaluate, round to the nearest cent, we get $5,333.33 approximately for consumer surplus. So you can probably imagine that 1/3 is producing all of these threes there. So the producer surplus, that's the integral 0 to 200 of the line minus the supply formula. So that's the 0.0002 x squared plus 0.03x plus 100 dx. So we get negative 0.0002x squared minus 0.03x, and then 114 minus 100 is plus 14. Take the antiderivative. So all pretty similar to each other. And then evaluate from 0 to 200. And we will get approximately $1,666.67. So it looks like we ended up with like a 2/3 showing up here in this calculation. So the consumers and the producers both gain out of this equilibrium price and quantity demanded. The consumers really did well in this transaction. So collectively, they're saving over $5,000. But the producers are also making almost $2,000 in additional revenue. So this, like I said, equilibrium price is kind of the win-win situation. Consumers get to save a little bit of money. Producers gain a little bit of extra money. And so everybody finds that balance, that compromise economically. But this brings us to the end of section 6.2. It's one of our applications to business and economics for integration. When we come back in the next section, we're going to be looking at a couple more topics in kind of similar veins to these, also applying integration. So I will talk with you all in the next one.